Okay. So we're all on page 13, yes?
Yep.
Yeah.
And for those people who potentially are following us online, these notes are downloaded by efixx.co.uk under Teachers Corner. In Teachers Corner, my notes that we're currently working on at the moment are available for download. There is a video that precedes this, the video where we did a conduit calculation before this. I recommend, if you haven't watched that one already, go and watch that video. That video is not done through Skype. It's an actual Gary sitting in the classroom directly teaching that part of it. But we're now on to the problem solving section, which means we're working with tables E1, E2, E3 and E4 in Appendix E of the on-site guide, which we've got in front of us. But if you just joined this video, you're going to need that appendix open in order to work through this problem on page 13. When you download it, it might not be on page 13 of the EFIXX Apprentice Hub, but it's a picture of a piece of trunking with a straight piece in problem 1, a 90-degree bend in problem 2, and we'll work out what problem 3 is as we work through this section. So here we go. The diagram below shows a length of metal conduit joined to a piece of metal trunking. Work out the conduit sizes for the following 3 loads. Please lay out as previously explained. So in your notes, how I laid out the question, where I found the factor, multiplied by the number of conductors and added them together, etc. I expect you to lay them out exactly the same as we work through this. There's probably only a small blank piece of paper for you to work on. Do you agree? Mm-hmm. So you might have to be quite economical with what you're writing. Okay, so we're going to work through these. Perhaps we'll work through them almost together, and you do your written calculations to suit. Okay, so first problem then, problem number 1. The conduit is 3 meters in length and is dead straight. Do we all agree with that?
Yep.
Yep.
So straight away, that suggests to me, which tables am I going to be using?
E1 and E2.
E1 and
E2.
E2. I totally agree with that. We're going to be using E1 and E2. So tell me what pages they're on.
146.
146.
Yeah, just page 146 of our on-site guide is what we're going to be using. Let's have a look at the problem then. Problem 1 at the bottom says we've got load 1 contains 4 10mm squared single core PVC stranded cables, 4 1.5mm squared single core stranded cables. So we've got 4 1.5s and 4 10mm. Do we agree?
Yep.
Okay. What's the first thing we're going to need to do then?
Work out the cable.
Multiply the cables.
So first of all, the first cable size was, let's go with 10mm squared.
Yeah.
So 10mm squared. Which table do we now go to?
E1.
Okay, E1, table E1. So we're going to be using table E1 first of all. What is the factor, please, for stranded cables if they are 10mm squared?
146.
146. Okay, 146. What about the next one? 1mm, is it 1 or 1.5? 1.5mm squared. What's the factor for that from table E1?
31.
31. Okay. What do we now do from previous things that we've done? What do we now do with the factor we found for 10mm and the factor we now found for 1.5mm squared?
You do the amount of conductors times the factor.
Right. So how many 10mm cables did we have?
4.
So we had 4 times the 10mm. What was the number for the 10mm?
146.
146. And what about the 1.5 factor? How many do we times that by?
4 again.
4 as well. So we had 4 10mm and we had 4 1.5mm squared. So we end up with 4 times 146, 4 times the factor for that cable. And as we had 4 1.5s as well, we do 4 times the factor for that, which is 31. Do we agree with probably written down 4 times 146 equals and 4 times 31 equals? You agree?
Yep.
Tim, what did you get for 4 times 146?
584.
584. Do we agree?
Yep.
And what did we get, please, Ed, for 31 times 4?
124.
124. Do we all agree?
Yeah.
And the total being?
708.
708.
Do we all agree? 708.
Yep.
So what we've done there is we've got a piece of conduit that is 3 meters or less in length and straight. Ours is 3 meters exactly. It's straight, incorporates no bends or sets. So we're using tables E1 for our factor for our conductors and E2 for the factor for our conduit. We've now found the total factor for our actual cables to be 708. What do we now need the conduit factor in table E2 to be, please, folks?
The same as or equal to.
Yeah, so well done, Tim. Well done, Ed. So it's got to be 708 or greater. So when we go for now table E2, what is the factor for 20 mil conduit?
460.
460.
So we can't use it. What's the factor for 25?
800.
So 800. So if we took 25 millimeter conduit, that has a factor of, is it 800?
Yeah.
So therefore, what size conduit would we end up selecting?
25 mil.
We 100% have chosen a 25 mil conduit. So problem number one, a straight piece of conduit off a trunking has a 25 mil size because of the conductors we're installing in it. Why do we not want to put too many conductors into the actual conduit itself?
Breaking the cables. Stress on the cables.
Mechanical stress. We've talked about it off camera. It's nothing to do with grouping. We would have done that in a cable selection, which we'll do later on in the notes that we're working through. So that's the first problem done. Okay, so we use tables E1 and E2 in order to do straight piece. The next two pieces of conduit, do you believe we're going to be using tables E1 and E2?
No.
Yeah. No.
Okay,
no.
you said, you sure, Dan? You changed your mind?
No, because it has a bend. No, I just seen it.
Great. So we've now got a bend in it. So if we look at problem number 2, how many bends have we got in that?
One.
And a bend is made up of how many degrees for us?
90 degrees.
90 degrees. So we're going with that's got a 90 degree bend in it. And how long is it?
5 meters.
5 meters. Which tables are we now going to be using?
E3 and E4.
So we're going to use E3 and E4. Okay, let's find them then. So table E3 is on page 147. Do we all agree?
Yeah.
Okay, so we're going to be using that. But first of all, we need to know what's going into that conduit. That conduit in load 2 at the bottom of the page says it contains 6 2.5 millimeter squared cables. And it contains nothing else. Do you agree? Just 6 2.5s.
Yeah.
What might that be suggesting is going on the wall there at position 2 if I've only got 6 2.5s?
Just 2 radials.
Possibly.
Just sockets then.
Socket on what sort of circuit? It could be a radial or
a ring.
It could, yeah. It could be the fact I'm trying to say ring or radial, so it could have gone into another socket, etc. So we've got 2.5 millimeters squared. First of all, we need to find the factor. And which table are we going to use for that?
E3.
So we're going to be using table E3. So let's look at John then. John, what's the factor on table E3 for 2.5 mil cable?
30.
30. All agreed?
Yeah.
Yep.
Right, so that's 30. We now need to know the number of those conductors. The problem said it had how many, Ed?
6.
So we need to do 6 times the factor for 2.5, which is 6 times 30. Do you agree?
Yep.
Yeah.
And Dan, what's 6 times 30?
180.
It is. Did you use a calculator or did you use that maths mind of yours? So we got a factor now for the cables where there's only going to be 6 2.5s and it's incorporating bends. So we're in table E3. Our factor now is 180. Ed, what must the factor of the conduit be?
2.5 times the diameter.
Really, Ed? Where did you get that one from? We're not talking about bending radius, mate. What must the factor of the conduit be?
It must be equal to or more than.
More than what number?
180.
180. So we've got the factor. We now need to go to table. Yes, I'm going to leave it in as well, Ed. I'll probably put a flashy.
Oh, he's recording it as well. No, I'm going to start swearing now.
We know the rules.
Yeah,
so we're now going to go to table E3 or E4. Which one are we going to next?
E4.
E4 is the one now with the conduit factors, yeah? So we're going to now whip over to E4 and we're going to have a look on there. Now, we know from previously looking at this looks a little bit more complicated, but obviously isn't. We're going to first of all need row number 1. John, do you agree?
Yeah.
And how long was my conduit when I'm looking at row number 1, John?
5 meters.
Yeah, so we scroll down to 5 meters in column number 1. And then we've got to work out how many bends we had in it. Tim, how many bends were in the conduit?
We had 1 bend.
We had 1 bend. So we go down to 5 meters and we scroll across. If I say to you, John, if it was 1 bend and 5 meters long and it was 16 mil conduit, what was the factor for it?
150.
Do we all agree?
Yeah.
Yeah, but
Yeah.
sorry guys, it's not 6 meters says over there.
Is it
Not
6?
five.
It's 5 on my notes. It's 6 conductors, but the drawing's 5 meters. Dan, look at the top picture.
Aha, okay.
That's all right.
That's
Okay.
Sorry.
Just apologise. It'd be nice.
Sorry, I said sorry.
Again, maybe.
Nah.
So again, but point done there, isn't it? You've not that, but it's easy. He's on 6 conductors. He's thought 6 meters. Now we're in a different part of the table. So again, for the exam purposes, it's concentrating on what we've got as the information. So we come down 5 meters. I've gone across to one bend, and the factor, as John's quite already said, is 150 for 16 mil conduit. Can we use that, Ed?
No.
Because we need the number to be what number?
Bigger than 180, or the same as.
Yeah, equal to or greater than 180. So we jump across, Tim, to the next conduit size at 5 meters with one bend. What's the factor for the next conduit size?
244.
244. What size is the conduit, Tim?
That's 20 millimeter.
Are we happy, Dan, to use 20 millimeter conduit, 5 meters in
Yes.
length with one bend? We are. Yeah, so we got,
180.
we did 20 mil conduit. And that had a factor of 244. Yeah.
Yep.
Therefore, we select a conduit for problem number 2 of 20 mil. All agreed?
Yeah.
Yep.
Okay. Now it gets a little, because we know with Gaz's question, we get slowly more difficult and more difficult. So we're now on to problem number 3. Problem number 3 suggests, from looking at it, which tables are we going to be using?
E3 and E4.
E3, E4, yeah.
Absolutely. E3 and E4. We've had a discussion prior to this about this this job. How many bends are there in it?
1.
One
Four
bend?
bends.
4 bends?
2.
4
2.
bends.
Wow. 18 bends.
Yeah. There's
What's
2
the bet?
bends at 45 degrees, which makes one bend out of 90.
Yeah, it does. And how many 45s are there in it?
2.
2 45s?
Oh. No, 4.
But you can see how we progress it. Yeah. So we've had a bit of everything there, haven't we? We've gone with 2 bends, 3 bends, 4 bends, 16 bends, whatever we've gone. We've come down the conduit system. We kick and then kick back, gives me a 90-degree bend. We come down, we kick and kick again, gives me a 90-degree bend. For me, this is 2 bends, and how long is it?
8 meters.
8 meters.
8 meters. Okay. We did say off camera, if we had just a kick in a conduit, 60, 40, 80 degree, whatever it was, we class that as a bend. But in this case, we've got 2 45s make a bend, 2 45s make a bend. That conduit has 2 bends in it, and it's how long, Ed, again?
8 meters.
8 meters. Okay, we'll go with that 8 meter conduit. I know where I've put my line on the drawing. Somebody will say, well, it ain't quite 8. We're going with it's 8 meters in length. Okay. Are we happy with that, Dan?
Yeah.
So now we need to look at, now we know it's 8 meters and 2 bends. We need to look at the cables going into it. Load 3 contains 16 1.5 millimeter squared cables. That's straightforward for us. So we first of all need to find the factor for 1.5 millimeters squared using which table again?
E3.
E3. So let's go back to E3. And if I ask John, what is the factor for 1.5, please, John, on E3?
That's 22.
I agree. How many of those have we got, Ed, again? Just remind me.
What's that? The internet went out then.
How many of those have we got? How many 1.5s have we got?
16.
So we do 16 multiplied by the factor of 22.
Yep.
And then need an answer of, you done it, Tim?
Yep.
What's 16 22s?
352.
Do we all agree?
Yep.
Yeah.
So that is the factor for the cables. And we know, Ed, what must the factor of the conduit be?
Equal to or bigger than.
Yeah, sure, M2.5?
Yeah, I'm pretty sure. I was reading the extra stuff at the bottom.
That's good. So now, which table are we now into? Which table do we need next?
We're on E4 now.
We go now back into E4. So let's have a look at that. First of all, column number 1 then, Dan. How long was my conduit, Dan?
8 meters.
So we come down column number 1 to 8 meters. We now know that the factor is 352, and we also know how many bends are in it. John, remind me how many bends are in that conduit.
2 bends.
There was 2 bends. So I'm looking at 8 in column 1. I'm scrolling all the way across to 2 bends. just a quick thing for you folks. Could I have 3 bends in that conduit?
No.
No. Could I have 4?
No.
Yeah.
I couldn't. 8 meters long. The most amount of bends you can have is how many?
4.
Not 4 bends.
I'm just winding you up now to see how far I push you.
After 19 years, I got finally broken by Ed Bryce. Okay, so
Winner.
but you notice at the top of the page, what's missing? Where's the typo at the top of the page?
Yeah, there isn't one.
Yeah, there's no 3 bends, is there? They've missed it out.
Yeah.
So we go straight 1 bend, 2 bend, 4 bends. Actually, we've missed out 3 bends. So just to show you there that if you had a piece of conduit 8 meters long with 3 bends in it, can you install it?
No.
You can't. You can't do it because it runs out of room. Those areas where there's no numbers means we're beyond the abilities of the actual system to pull it in. But we're okay because ours is 8 meters long and it is 2 bends. So we're okay. So if I said to John, 8 meters long and it was 16 mil conduit, what would the factor be for 16 mil?
97.
Wow. Okay. So it's obviously not that one. If I said to Tim, it was 20 mil and 8 meters long with 2 bends, what's the factor?
159.
Again, nowhere near. I'm worried now. Ed, if it was 25 mil and 25 mil, 2 bends, 8 meters long.
292.
We've got one left, Dan. What conduit can I choose?
32 millimeters, 529.
It's got a factor, so 32 millimeter as a factor of 529.
Nine, yes. And
So
it's bigger than 3.2, so use this one.
So the conduit must be 32 mil. Do you agree?
Yep.
Yeah.
With a factor of 529. Wow, we were close to having a major problem now, weren't we? Because we've got one conduit left.
Yeah.
Look at the drawing again. How can I solve that problem? So we're okay. We're okay. Let's say I made it 10 meters long. That conduit was 10 meters long. Can I now have a 10 meter long conduit? I can. I'm just about in on 32 mil. Yeah. Logically, what could you do to the conduit system to ease the pressure on the calculation?
Remove the bends.
I could,
Yeah.
but I need those bends.
Ah.
So think of something else. What else could I do?
Reduce the cable size.
Using it.
I'm not going to reduce the cable size because it's needed for the load. So we've got at the moment double set to an accessory 8 meters long. What could I do?
You have to increase the size of the trunking, the conduit.
I don't want to do any of those. What else could I do to ease the pressure on the calculation?
Put an inspection hatch in halfway through.
I could just put a through box. So bang in the middle of that conduit here. If I put in just there a through box, yeah. How long would the conduit be then before it hit the exiting point of the system?
4 meters and 4 meters.
And how many bends would I have in it?
1.
Well, let's investigate. So let's just look at that again. So now I've got a 4 meter long and 1 bend. Agreed?
Yeah.
Yeah.
I've still got the same factor, 352. We chose for the original problem 32 mil conduit. Let's go back again. Let's look 1 bend, 4 meters. So 4 meters, 1 bend.
It's 463.
What size conduit am I now using?
25 mil.
25 mil. 25 mil conduit run 32. So from a design aspect, wouldn't it be better to perhaps have that box in there? And then use 25 mil. It's probably for a number of reasons. 25 mil conduit is readily available off the shelf stuff. We're talking it's obviously a little bit easier for us to bend. 32 becomes a bit of physical effort. You've got to make sure you've got 32 mil formers, 32 mil stocks and dies, etc. And 20 and 25 are most common. A simple change by inserting a box means that all of a sudden now we're only looking at the worst element of the run. The worst element in this case, we've halved it. So we've only got 1 bend and it's 4 meters in length. So I think it just concludes looking at a system from a design aspect is that just because you can get that conduit system in at 8 meters with 2 bends and it's 32 is our last chance to get it in, sometimes it's not the way forward when simply putting another box in can make life a little bit easier. Does that make logical sense, folks?
Yep.
Yeah.
Are we all happy with that section?
Yeah.
Yeah.
The exam's more likely to ask you for either a factor for a cable or the factor for conduit. It's a multi-choice exam. It's very unlikely to want you to do a calculation. But as we move towards a domestic installer course, and you've got to install either, well, you've got to do both plastic and steel conduit, I'd like us to be able to look at the conduit system, look at the worst part of the run, and be actually factor it in, and also know how far away from a bend or a fixing point must we have a saddle. What's the maximum distance away from a bend? Absolutely. And we found it in the answer guide. And Ed, just to throw you this one, what's the diameter of the conduit multiplied by the factor of in order to work out the bending radius?
No idea.
No idea. Okay, John.
Sorry, I missed that. Sorry.
Ah, Dan.
Sorry.
So it's 2.5 times diameter.
2.5.
And on that bombshell.